Today is a big day. We are going to talk about the 5-number summary today. Once again, your normal reminder to put the date on top of this. The 5-number summary includes the 5 numbers that you see there. The minimum, something we call Q1, the median, something we call Q3, and the maximum. The median, the minimum, and the maximum, those are words that you should have seen before. The quartiles, which are Q1 and Q3, you probably have not seen before. Okay, so let's talk about those. So a quartile contains 25% of the data. So within that quartile, you should find 25% of the data that you've collected. There are 3 quartiles. There's the first quartile, the second quartile, and the third quartile. So if we're thinking about quartiles, here is the minimum. "25% of the data is contained here. This is called Q1, the first quartile. It's a quarter of the way up the list. We keep going. There's 25% more here till we get to Q2, which is also called the median. 50% up until there. We break it up into another chunk with 25%. We have Q3 until we get to the max value, which still contains 25%. Okay. The first quartile is a quarter of the way up the list, Q1, Q3. Okay. We'll talk about finding quartiles on the next page. There's also something called the interquartile range, the IQR, and that's going to be the middle 50% of the data. So if I look back to my little graph I've drawn up here, that's going to be this right here is the IQR, the middle 50%. So in order to find the spread of the IQR, you take Q3 and you subtract off Q1. That's the formula you use for IQR. Okay. We use that on the next page too. Okay. So let's look back at this picture here. Does this look like anything you've seen before? Do you remember what a box and whisker plot is? Maybe, maybe not. A box and whisker plot is the 5-number summary. Okay, so let's make a box and whisker plot. We're going to find all of the numbers of our 5-number summary. So up here on the next page, we have Barry Bonds home runs in the 2007 season. And they're listed there. Notice that they are not listed in number order. So the first thing you'll need to do is pause the video and put the numbers from lowest to highest. And you can just write them right below. So there's all the numbers from highest to lowest. You'll notice that I've put a spot for us to write the minimum, the Q1, the median, the Q3, and the maximum. Let's go ahead and do the minimum and the maximum first. So the lowest number on here is 16. The maximum number is 73. Okay, next thing let's find is the median. So we talked about this very briefly before, but now let's talk about it for real. If you want to find the median, you need to cross off numbers. And you cross off one from the high end and one from the low end until we find the true middle. I'm not going to just straight cross these off because I want to be able to read these later. So I'm just going to put a dot when I've crossed them off. So I'll put a dot at 16. And I'll put a dot at 73. And then I'm just going to keep going. 24, 46, 25, 46, etc. until you find the middle point. Sometimes I like to box it. Okay. So that's the median. That's the middle number here. 34. Next thing we're going to do is we're going to find the median of the lower half and the median of the upper half. Okay, so I'm going to ignore the 34 because if I ignore it, since there's an odd number of data points here, if I ignore it, I'll have an even number on both sides, okay, the same number. And now I'm going to cross them off because I don't need to see anything anymore. And I'm going to ignore everything from the median up. So when I cross them out, I'll cross out 16 and 34. I'll cross out 19 and 33. I'll cross out 24 and 33, 25 and 28 until I get here. Okay, well now Q1, I need to find the median of this part, so I'm going to take the average of those two. So my Q1 will be 25 and a half, okay, which is 25 plus 26 divided by 2. So I found the median of my lower values. That's how I got that number. Okay, same thing, we'll find the median of the upper values. So again, ignoring everything below and equal to this 34, cross out the 37 and the 73, and just keep going. Should have to average these if I had to average those. Average of that is just 45. So there's your 5-number summary. So let's take a look here. This number, 25 and a half, includes 1, 2, 3, 4, 5 pieces of data. This one includes 1, 2, 3, 4, 5 pieces of data. This one includes 1, 2, 3, 4, 5 pieces of data. 1, 2, 3, 4, 5 pieces of data. Okay. So there's my quartiles, Q1, Q2, and Q3. They all include 25% of the data. So they all include 5 sets of data, 5 pieces of data. All right, so when we make a box plot, sometimes also called a box and whisker plot, Q1, the median, and Q3 are all designated with lines. So I'm just going to make straight lines here at 34. And actually, we do need to kind of make a scale here. So let's make our scale first. So it goes from 16 to 73. Maybe I'll make mine go from 15 to 75 by 10s, maybe. Maybe I'll just go by 10s. It's not going to be perfect. Oh, that's all right. Okay, so I'm going to make my box plot just over here. And my median is at 34, so just somewhere below this 35 is my median. My Q1 is at 25 and a half, so about here at 25. I have another median at 45. Okay, so make my box around those. The minimum and the maximum both get dots. So I have a dot at 15, and there's the whisker, a dot at 73, and there's that whisker. Okay, so what this is telling me here is that I know that 25% of my data is in each of these chunks. This chunk is longer than all the others. So that means even though it's longer, 25% of the data is still here. It's not that it has more data, it's just that it's further spread apart. So the difference between 45 and 73, which are our two endpoints on this little segment right here, is a lot wider than the difference between either of these three. The difference, this one goes from 16 to 25, so about 10. This one goes from 25 to 34, okay. 35 to 45, okay, so about 10 on all of those. And then this one goes about 20, so it's about twice as long as those. Okay, so this is kind of the main gist, how to find these numbers. We'll talk about analyzing these later, okay, but for now, if you can understand how to find these numbers, that's a really good start. Finding the IQR and finding Q1 and Q3 also helps us find these things called outliers. We've talked about outliers before, but we've never really given a formal definition to it. So what's cool about these numbers is that this gives you a hard and fast rule about what makes an outlier. So an observation is a true outlier if it falls more than 1.5 IQR above or below Q3 and Q1 respectively. So what I have down here in purple is the formulas. So it needs to be less than Q1 minus 1.5 times IQR, or more than Q3 plus 1.5 times the IQR. Okay, and on a box plot, you'll see outliers marked with an X. Okay, so let's look at this next example. It's the last one we're going to do today. And we're not going to add our own data today. So let's just look at these travel times that it takes to get to school. And I'm going to make a box plot. So actually what I want you to do is see if you can use what we did in the last example about Barry Bond and find at least the 5-number summary. And then we'll talk about making the box plot and so on and so forth. Okay, so pause the video and go ahead and do that. Okay, so I've got here the start of my box and whisker plot. I found all of the numbers that it was required to find. So let me just go ahead and finish this out here. This is what yours should look like as well. Don't forget that scale at the bottom. Now let's see if we have any outliers. So the first thing we'll need to do is find the IQR, which is equal to Q3 minus Q1. So that's 20 minus 7, which is 13. Okay. The next thing we're going to do is take Q3 plus 1.5 times the IQR. So if we plug our numbers in, we've got Q3 is 20 plus 1.5 times 13. So we've got 39.5. Our other bound is Q1 minus 1.5 IQR, which will be 7 minus 1.5 times 13, which is negative 12.5. Okay, so our requirements to be an outlier is that it's greater than this number and less than that number. Well, we definitely don't have any less than that. We're not going to have anything in the negatives. We don't either have something that's above 39.5. So in this example, this is the proper box and whisker plot. There are no outliers. What I want us to do is, for the purposes of this, let's change this last one to 45. Let's say it takes someone 45 minutes to drive to school. Okay, well now we do have an outlier. That outlier is at 45. So it doesn't change anything. I mean, you can see here, and we would have found the exact same Q3, the exact same Q1, and exact same median. The only thing it really changes is our max value. So let's extend this out to 45. I'm going to put an X at 45 because 45 is an outlier. And then I would shorten this to 25 because our next highest value is at 25. And I wouldn't need the rest of that stem. Okay, so that's what our new box and whisker plot would look like if we converted that 35, or the 35, I'm sorry, to a 45. Let's compare this with a dot plot. So here, and we can actually almost line them up the exact same. This is the dot plot of this same data. What do you notice about the dot plot? What's the shape? Skewed to this direction, skewed to the right. And you'll notice that the majority of the data is concentrated right here. That's really, really, really important in terms of a box and whisker plot. Notice how this line and this box are really short. There's 25% of the data in this really small space. There's also 25% of the data in this wider space. So when you see the smaller lines on a box plot, it's going to account for more data in that portion, more data in the next portion. There's still the same amount of data, it's just more spread out in this next portion and then really spread out towards the end. Okay. So that's kind of how those two relate. We'll talk more about how they relate, but write something down about this or draw this picture on there too, because that's going to be really important as well. So there's box plots. We're going to get lots more practice with those. And that's it for box plots.